Today we are discussing with one of the important chapter, our CBSE board textbook, real numbers. That is, what is meant by a real number? A real number means a connective of number system. That is, very beginning all of you know very well about the natural numbers. Natural numbers are the numbers which we generally use for the counting. That is, in the least number of the natural numbers is the 1 and the highest number is cannot define. That is, n is equal to set of 1, 2, 3 and so on. That is, in the set of natural numbers, the least number is the 1 and the highest number we cannot define, and the set of natural numbers are denoted with capital N. Next, set of whole numbers. How to define a whole number? Whole numbers are the numbers. To the natural numbers you include 0, then the set of numbers formed is called a set of whole numbers. That means in the set of whole numbers, the least number is a 0 and the highest number is not defined. Next, what is meant by a integer? Next, set of integers. How set of integers will form? The set of the group of negative numbers and the positive numbers together 0 will form a set of integers. Integers are denoted by the letter I or Z. That is, -4, -3, -2, -1, 0, 1, 2, 3 and so on. That means the least number of the integers we cannot define, and at the same time the maximum number of the integers also we cannot define. Next, irrational number. How to define a rational number? Rational numbers are denoted with the letter Q. Very beginning, what is meant by rational numbers? Rational numbers are of the form P by Q. That means a numbers are which are of the form fraction form, there is a P by Q form, are called rational numbers. Here P comma Q are collected from the integers, that is Z, and Q not equal to 0. This is the definition of rational numbers. Now we can discuss more about the rational numbers. That is, a number which are of the form P by Q are all rational numbers. Yes, the numbers which we can mention in the form of P by Q or we can call as a rational numbers. Now see, after this one, every rational number can be expressed as in two different forms, that is either terminating or non-terminating repeating. Next, what are the mean by terminating decimal? Terminating decimal means which will get the remainder 0. Suppose for example 5 by 2. 5 by 2 nothing but 2.5. Next, secondly 10 by 3. 10 by 3 means approximately there is a 3.33333, so on, that which is called as 3.3 bar. That is, which is a terminating decimal, which is a non-terminating repeating decimal. That is, terminating, non-terminating repeating, non-terminating repeating. These two are called rational numbers, denoted with Q. That means every rational number can be expressed as either terminating or non-terminating repeating decimals. Then one more, decimals are 3 in types. Number 1 terminating, number 2 non-terminating, number 3 non-terminating repeating. Among the 3, 2 are selected as rational numbers. Then what about the third one, which is called as an irrational numbers? That is, irrational numbers are denoted with, next one, non-terminating repeating over. Next, non-terminating. Non-terminating decimals are denoted with q dash, that is irrational numbers. Therefore, the union of, that is union of rationals and irrationals, we can call as a real numbers. That means, in some people we also, they mention q dash also with s. Therefore, what we understand mean by real number? A real number is a combination of rational and irrational. Okay, from our previous knowledge, we can decide that all natural numbers are whole numbers. That is, natural numbers is subset to whole numbers, and all whole numbers are integers. That is, whole numbers is subset to integers, and all integers are subset to the rational numbers. Now, in the number system, the least number system is the natural numbers, and the biggest in this group is the rational. Now, q dash is separate from this. That means q and q dash are quite different to each other. Now, that is, if you combine these two, that is rational numbers union irrational numbers, will gives you a real number. Okay, our next topic is Euclid's division lemma or Euclid's division algorithm. We know the meaning of algorithm. Algorithm means a step-by-step procedure to solve the problem. And then lemma. Lemma means which is a connective to a theorem or a part of a theorem. Now, let a comma b are positive integers. Let a comma b are the two positive integers, then there exist unique q comma r, then there exists unique nothing but one and only one, then there exists unique, here it is a very important word, unique, one and only one, unique q comma r such that a is equal to bq plus r. This is the condition where 0 less than or equal to r less than b. What are the positions of a, b, q and r? That is, a is dividend. Now, b is your divisor and q be the quotient and r be the remainder. Okay, now what are the positions of a, b, q, r are very clear here. Once again I do repeat, let a comma b are any two positive integers, then there exists a unique q comma r such that means here we can observe four different variables, that is a, b, q, r. They can arrange in the form of a is equal to bq plus r, and one of the very most important condition they must satisfy this one, that is your remainder is either 0 or greater than 0, and your remainder must be always less than b. Who is the b here? B is a divisor. Next, a is the dividend, b is the divisor, q is the quotient and r be the remainder. Okay, now how to find the HCF of the given two numbers or three numbers by using the EDL, that is Euclid's division lemma. Now let us consider the two numbers. First example, LCM of 24 and 38. First of all, follow the division method. One time 24, 8 minus 4, 4, 14, 24, one time 14, 10, one time 10, 4, 10, 2 times 8, 2, 4, 2 twos. We have to continue the process till you get the remainder 0. Therefore, your HCF is 2. It is a division method. With the help of this one, now how to do? Let us see. You know, A is equal to BQ plus R. Now let us identify the position. This is the A, B, quotient, this is the remainder. Follow these steps continuously. That is, first your A is 38 is equal to quotient is 1 time your quotient, B is divisor, that is a 24 times quotient is a 1 plus the remainder is 14. That is in the second step. In the second step, 24 is your new dividend. That is 24 is equal to 14 into 1 plus remainder is 10. In the next step, what is your new dividend? 14 is your new dividend. 14 is a breakdown into 10 into 1 plus remainder is 4. 10 ones are 10 plus 4, 14. Next, what is your new dividend in the next step is a 10. 10 will be write as 4 times 2 plus remainder is 2. 4 twos are 8, 8 plus 2, 10. Next dividend is 4. Then divisor 2 into quotient is a 2 plus remainder is 0. That is, you have to continue this process until you will get the remainder 0. Therefore, this part is called now HCF, highest common factor. Therefore, conclude the answer. Therefore, HCF of 24, 38 is 2. Let us follow the next example. Second example, 45 and 26. From these two, 26 is the least. 45, that is 1 time 26. That is 5 minus 6 is not possible. Come on, borrowed, get borrowed. 15 minus 6, that is 9. 1 is borrowed, 3 left. 3 minus 2, 1. 26. Again 1. 19. 7. 19. 7 threes are 21. Therefore, 7 twos are 14. The remainder is 5. 1 time 5. 7 minus 5, 2, 5. That is 2 twos, 4, 1, 2, 1 choose 2, now the remainder is 0. Continue the process till you will get the remainder 0. Therefore HCF is 1. Now based on this one, now you can prepare the data. Come on, first 45 is your dividend, first dividend, divisor, quotient, remainder. That is 45 can be break down into 26 into 1 plus remainder is 19. That is A is equal to BQ plus R. That is next. What is your next dividend? 26. 26 is a breakdown into 19 into 1 plus remainder is 7. Next 19 breakdown into 7 2s are 14 plus remainder is 5. Next 7 breakdown into 5 1s are plus 2. Next 5 breakdown into 2 times 2 plus 1. Next 2 breakdown into 1 times 2 plus 1 times 2 plus remainder is 0. Therefore this part is called HCF. Therefore conclude the answer. HCF of what are the two numbers? 26 and 45 is 1. Next, the rest of the two numbers you can solve in the same way. Next model is find the HCF of three numbers are given here. Find the HCF of the three numbers by Euclid's division lemma. Now, first of all, find out the HCF of any two numbers. By using these two numbers, you will get the HCF. With that number, you can go through the third one. Now, let us see. First, we will go through by the division method. Now, from these, collect the first two numbers. That is, from these two, the least number is 1794 2346. It is a 1700 around. This is 2300 around. That is one time 1794. 6 minus 4 2. 14 minus 9 5. Here 1 borrowed. There is a 12 left. 2 left. There is a 12. 12 minus 7 5. Next, from here 1 borrowed, 1 left, 1 minus 1 0. 5 5 2 1794. Go for the estimation method. It is a 500 something around. This is 1700 something. That is, let us check with 3 times. 5 5 2 3. How we know 5 times means 5 3s are 15. That is around 1500 range. Suppose if you place here 4, 5 4s are 20, there is a 2000 range. But here only 1700 is there. Okay, that is why 6, 15, that is 16, 1656. 1656. How many times? That is a 3 times. Next, 14 minus 6, that is 8. Here 1 borrowed, 8 left. 8 minus 5, that is a 3. 7 minus 6, that is a 1. Now shift 5 5 2 here. Again, this is 130 around. This is 550 around. That is, now I will 138 4. I will see 138 4. That is 32, 12 plus 3, 15, 4 1s 4 plus 1, that is a 5, 552. Okay, 552. That is the remainder is 0. That is how many times? 4 times. Therefore, your HCF is 138 which is HCF. Now I have to by Euclid's division lemma method, but this is the division method. After this one, you know how to frame the next steps. Come on, your first dividend 2346 can be break down into 1794 into 1 plus the remainder is 552. Next, your new dividend is 1794, which will be break down into 552 into 3 plus remainder is 138. Next, 552 can be break down into 138 into 4 plus 0. Therefore, 138 is HCF of what are the two numbers? 1794 and 2346 is 138. Now, take this 138 and the next number is 4761. That is, see, it is in hundreds, it is in thousands. There is a lot of gap between the two numbers. Now let us check. Suppose 10 times 1300 will come. 2 times, that is 13 2s 26, 2600. 3 times 13 3s are 39, that is which is the nearest. 4 times means there is a 4200, that is, let us check with 138 into 35. Take first 35 times I will. 5 8s are 40, 5 3s are 15 plus 4 19, 5 1s 5 plus 1 6 into 3 8s are 24, 3 3s are 9 plus 2 11, 3 1s 3 4, that is 0, 9 plus 4 13, 6 7 8, 8, that is a 4830, but here only 4700 is there. I taken 34 times. Now just you can subtract 1, that is 138 fours you can collect here. 138 34s, that is 8 fours are 32, 12 plus 3 15, 4 ones 4 plus 1 5 into 3 8s are 24, 3 3s are 9 plus 2 11, 3 ones 3 plus 1 4, that is 2964. That is a 4692. Okay, we can 34 times 4692. Now 1 minus 2 is not possible. 11 minus 2 9, 1 borrowed here 5, there is a 15, 15 minus 9 6, 1 borrowed here 6 minus 6 0, 69, 138. Now that is 1 time, 2 times means 140, 2 times 69 2s, 9 2s 18, yes 138 is sufficient. Therefore 69 is the LCM of, sorry, 69 is the HCF of the given two numbers. Therefore, arrange this one. 4761 is equal to 138 into 34 plus 69. Next, 138 is equal to 69 into 2 plus 0. That is, therefore, this is, that is HCF of 1794 2346 4761 is 69. Okay, let us see our next problem. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. We know very well every even integer is of the form 2q and every odd integer is of the form 2q plus 1, that is either 2n or 2n plus 1. That means every even number can be expressed as the multiple of 2, that is the 2n. Every odd integer can be expressed as in the form of 2n plus 1. Now here from the question, now we have to show that 6q plus 1, 6q plus 3, 6q plus 5 are shows only odd integers. Now let A be the positive integer, comma B be the quotient, comma R be the remainder. When A is divided by 6. Sir, why you taken as a 6? Why not some other number? Here your pattern is a multiple of the 6. Now then by EDL, means by Euclid's division lemma, you know very well A is equal to 6q plus R. That is, here the condition is, here first of all write the definition. A is equal to BQ plus R, where 0 less than or equal to R less than B. Here I told that when A is divided by 6, A is divided by 6 means next step A is equal to, you can write 6q plus R. That is 0 less than or equal to R less than, in place of B what number is there? 6 is there. That is your R values are, R value is less than 6 and must be equal to 0, that is a 0, 1, 2, 3, 4, 5. Why? Because your R value is less than 6. That means less than 6 means you can consider only up to the number 5. That is, let us consider the cases. When R is equal to 0, when R, if you place R is equal to 0, it will become A is equal to 6q. If R is equal to 1, it becomes A is equal to 6q plus 1. If R is equal to 2, you place A is equal to 6q plus 2. If R is equal to 3, you place A is equal to 6q plus 3. If R is equal to 4, you place A is equal to 6q plus 4. If R is equal to 5, you place A is equal to 6q plus 5. That means 1, 2, 3, 4, 5, 6. Among the 6 values, which can be further simplified? It can be further simplified. It can be further simplified. It can be further simplified. That is, A is equal to 6q, nothing but 2 times 3q. Next, A is equal to 6q plus 2, 2 times 3q plus 1. Next, a is equal to 6q plus 4, 2 times 3q plus 2. Clearly, these are even. Why you consider these are even? Multiple of 2, multiple of 2, multiple of 2. Therefore, clearly a is even. Clearly, a is even. Okay, let us consider the next steps. That is, a is equal to 6q plus 1, a is equal to 6q plus 3, a is equal to 6q plus 5 are odd integers. Come on, let us place in place of q. You place any number. I want to place 1. 6 ones are 6 plus 1, 7. Here I want to place 2. 6 2s are 12 plus 3, 15 is an odd number. Here I want to place 3, that is 6 3s are 18. 18 plus 5, 23 is an odd number. Okay. Therefore, from the question, here the 6q plus 1, 6q plus 3, 6q plus 5 are odd integers where q is some integer. Okay. Therefore, I conclude that a is an odd integer for 6q plus 1, 6q plus 3 and a 6q plus 5. See, our next problem is, use EDL, show that the square of any positive integer is either of the form 3m or 3m plus 1. That is, if you take any integer, do square, the result must be either of the form either 3m or 3m plus 1. Let a be the positive integer. Let a be the positive integer and b be the quotient. B be the quotient, comma, R be the remainder. R be the remainder when A is divided by 3, then by EDL, means Euclid's division lemma. What you will write? Formula A is equal to BQ plus R, where 0 less than or equal to R less than B. Then A is equal to, your B value is 3Q plus R, that is 0 less than or equal to R less than 3, because your B value is 3. That is R is equal to, R value 0 takes, 1 takes, 2 takes. That is, if R is equal to 0, what will happen? A is equal to 3Q. Now, if R is equal to 1, A is equal to 3Q plus 1. If R is equal to 2, A is equal to 3Q plus 2. Yes. For different values of R, here we got 3 different cases. Please see the question once. What the condition is? Square of any positive integer. That means if you do the square to each case, the output must be either 3m or 3m plus 1. Okay, let us take the case 1. Case 1. A is equal to 3q. Squaring on both sides. That is, a square is equal to 3q whole square. A square is equal to 9q square. That is, a square is equal to, this is I can write as 3 into 3q square, which is nothing but 3m, 3 into m, where m is equal to 3q square. Here I can see square of any number is of the form 3m, where m is some integer. Now come to the case 2. come to the case 2. A is equal to 3q plus 1. Now squaring on both sides. A square is equal to 3q plus 1 whole square. A square is equal to, you can write as a plus b whole square. That is a plus b whole square means a square plus 2ab, 2 into 3q into 1 plus 1 square. That is a square is equal to 9q square plus 6q plus 1. That is a square is equal to, from these two I want to take 3 as the common. That is the rest part is 3q square plus, that is 2q plus 1. Therefore a square is equal to 3m plus 1, where m is equal to 3q square plus 2q. Now say square of any number is of the form 3m plus 1, 3m plus 1 form. Okay, now come to the case 3. Case 3, a is equal to 3q plus 2. Again squaring on both sides. A square is equal to 3q plus 2 whole square. That is a square is equal to, I will write directly this one. That is 9q square plus 2 into 3q into 2 plus 2 square nothing but 4. That is a square is equal to 9q square plus 2 3s are 6, 6 2s are 12q plus this I can break down as 3 plus 1. That is a square is equal to, I will take 3 common from this one. Now if I take 3 common, 3q square plus 4q plus 1 plus 1. Therefore a square is equal to 3m plus 1, where m is equal to, this is the m is equal to 3q square plus 4q plus 1, where m is some integer. Now let us see the conclusion. Square of any number is of the form 3m. Square of any number is of the form 3m plus 1. Next, square of any number is of the form again 3m plus 1. Therefore I conclude that the square of any number I can express is in the form of 3m or 3m plus 1. See your next problem. Use the EDL. Show that cube of any positive integer is either of the form 9m, 9m plus 1 and 9m plus 8. Let a be the positive integer, b be the quotient and r be the remainder when a is divided by 3. Then by EDL, a is equal to bq plus r, 0 less than or equal to r less than b by definition. Now a is equal to 3q plus r, 0 less than or equal to r less than 3. That is r is equal to 0, 1, 2. Now if r is equal to 0, a is equal to 3q. If r is equal to 1, a is equal to 3q plus 1. If r is equal to 2, a is equal to 3q plus 2. Then consider the each case and you have to cube it. Now case 1. A is equal to 3q, cubing on both sides, which will gives you a cube is equal to 3q whole cube, which is equal to 27q cube. That is, you can take 9 common in this one. If you take 9 common, 3q cube, that is equal to 9m. Therefore a cube is equal to 9m, where m is equal to 3q cube and m is some integer. That is, cube of any number is of the form 9m. Next, consider the case 2. Consider the case 2. A is equal to 3q plus 1. A cube is equal to 3q plus 1 whole cube. That is, a cube is equal to a plus b whole cube. That is, a cube plus 3a square b, 3a square b plus 3a b square plus b cube nothing but 1 cube. That is, a cube is equal, write directly, 27q cube plus 3 square nothing but 9, 9 3s are again 27q plus 3 3s are 9q plus 1. That is, a cube is equal to, from here to here, please take 9 common. If you take 9 common, 3q cube plus 3q plus q plus 1. Now, a cube is equal to 9. The total part I imagined as m, 9m plus 1. Now, where m is equal to 3q cube plus 3q plus q. Therefore, cube of any integer is of the form 9m plus 1. 9m plus 1. Therefore, come to the case 3. Come to the case 3. That is, a is equal to 3q plus 2, cubing on both sides, a cube is equal to 3q plus 2 whole cube. That is, a cube is equal to a cube plus 3a square b plus 3a b square plus b cube. That is, a cube is equal to 27q cube plus 3 square nothing but 27. Sorry, 3 square nothing but 9. 9 3s are 27. 27 2s 54q plus 3 3s 9. 2 square nothing but 4. 9 4s are 36q plus 2 cube nothing but 8. That is, a cube is equal to, from here to here, please take 9 common. If you take 9 common, the rest parts are 3q cube plus, next 9 table, 9 6 are 54, 6q, 9 4s are 36. Here 9q square will come, that is q square, that is 9 4s are 36, q plus 8. That is, a cube is equal to 9. The total part I considered as m plus 8. Therefore, cube of any integer is of the form 9m plus 8. 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. Therefore, I conclude that cube of any positive integer is of the form the 9m, 9m plus 1 or 9m plus 8. See, that is 9m, 9m plus 1, 9m plus 8. Observe your LHS parts. Cube of the natural number, sorry, cube of the number, cube of the integer, cube of the integer. See your next problem. Prove that root 2 is an irrational number. We know very well the square of any number we cannot express it as a whole number. Such numbers are called irrational numbers. Suppose for example root 2, root 3, root 5 and so on. Suppose for example root 4, let us take root 4 is equal to, I can express root 4 nothing but as a 2. Therefore root 4 is not an irrational number. Suppose for example root 9, let us take, I can express as 3. It is not a irrational number. Now suppose for example root 5, I cannot express as a whole number. Answer. Root 3, I cannot express. Root 6, I cannot express. Root 7, I cannot express. Root 8, we cannot express. Therefore the numbers which we cannot express as a whole number under the root, such numbers are called irrational numbers. Okay. Now let us observe. Let us assume root 2 is a rational number. Root 2 is a rational number. Now you know very well, every rational number can be expressed as p by q form. That is root 2 is equal to a by b. Clearly here one condition, a and b are co-primes. A and b are co-primes here. That is, what is the meaning of the co-primes? A and b do not have the factors, common factors except one. That is, which is called as standard fraction. Now suppose for example root 2 is equal to a by b, squaring on both sides. Squaring on both sides means 2 is equal to a square by b square. Now cross multiply. A square is equal to 2b square, which is equation 1. A square is equal to 2b square, which is nothing but is 2 divides b square, a square. 2 divides a square. If you cross multiply, b square will come here, 2 will come here. Then the meaning is 2 divides a square. Then if 2 divides a square means 2 divides a. 2 divides a. 2 divides a, nothing but your a is of the form multiple of 2. 2 divides a. 2 divides a means your a is a multiple of 2. Now substitute a is equal to 2. This is equation 2. Now substitute equation 2 in equation 1. That is, in place of a, that is a square is equal to 2b square. A nothing but 2k whole square is equal to 2b square. That is 4k square is equal to 2b square. That is 4k square is equal to 2b square. Therefore 2 table 4 get cancels 2 times. 2k square is equal to b square. Now from this condition, what I understand is, if you 2 is a multiple here, if you bring to other side, what shall I write? 2 divides b square. 2 divides b square. If 2 divides b square means 2 divides b. See here, 2 divides a. Here I got 2 divides b. What is the mean for that? Here a comma b are the co-primes. Co-primes means they do not have the common factor. But according to the question, it is telling that 2 divides a and 2 divides b. That is 2 is common factor of a and b, which is impossible which is impossible because A and B are co-primes. Therefore, which is a contradiction. Why? Because A and B are the co-primes. Therefore, our assumption root 2 is rational is false. Therefore, why our assumption root 2 is rational is false. Therefore, root 2 is an irrational number. Okay, let us prove the next question, which is similar to your previous model. That is, previously we did root 2 is an irrational number. Now we have to prove root 5 is an irrational number. Now let us assume that root 5 is a rational number. That is, root 5 is equal to a by b. That is, rational number is of the form a by b. And here b must not equal to 0. And a and b are the co-primes. Co-primes means, once again I repeat, they do not have the common factor except 1. That is, now squaring on the both sides, that is square root get cancel, that is a 5. Now cross multiply, a square is equal to 5b square. A square is equal to 5b square. Suppose if you transfer this b square to here and 5 to this square, what is meant for that one? 5 divides a square, that is 5 divides a square. 5 divides a square means that 5 divides a also. That is, your a will be is of the form 5k, that is a multiple of the 5. Now substitute equation 2 in the equation 1. A square is equal to 5b square. That is, in place of a square you can substitute 5b square. That is 5b square. Now what is the value of the a? 5k whole square is equal to 5b square. That is 25k square is equal to 5b square. That is 5, 25 get cancelled. That is, what is left? 5k square is equal to b square. What is the mean for this one? If you bring this 5 to the denominator, 5 divides b square. If 5 divides b square, then that 5 divides b also.